let's look at solving higher degree polynomials, such as 6x to the third minus 11x squared minus 7x equal to 0. Now, we don't want to panic about this because let's look at this to begin with. What can we factor out? Remember to factor your greatest common factor out first. We can factor out an x to begin with. When we factor out an x, we are left with 6x squared minus 11x minus 7. Now this looks more familiar to us. This is a quadratic just like we're used to. So then we're going to factor using our AC method. A is equal to 6, B is equal to a negative 11, C is equal to a negative 7. So we're going to get A times C, which would give us a negative 42. And we need items that will add up to a negative 11. So I need a positive and I need a negative. So let's start with 42 and 1. Well, that's not going to help us any. 42 and 2. I'm sorry, not 42 and 2. 21 and 2. Well, that doesn't help us any. 14 and 3. That might help us. If we have a negative 14 and a positive 3. That will help us. Remember to place both of those over a 6, over your A. Then we're going to simplify these. So this can simplify. Divide both of those by a 2. I get a negative 7 thirds. Both of these will simplify. Divide both by a 3. I will get a positive 1 half. So I'm going to come back over here. I have my x that I factored out. Denominator gets the x. Numerator goes in back. Denominator gets the x. Numerator goes in back. Now you will notice I have 3 factors that have variables. So I'm going to set each of those factors equal to 0 and solve. So I have this one that's already solved, x equal to 0. So that is one of my zeros. Then I'm going to get 2x equals a negative 1. So x is equal to a negative 1 half. 3x is equal to 7. So x is equal to a 7 thirds. So I actually have 3 solutions here. And if you'll notice, my largest exponent, the degree of my polynomial, is actually 3. So my solution set is a negative 1 half, 0, 7 thirds. Now let's look at another example of this. And this one, I'm actually going to start out with 4 terms. I have 2x to the third plus 5x squared minus 8x minus 20 is equal to 0. Well, whenever I look at this, there's nothing that I can factor out of every single term. So I can't take a greatest common factor out. When I have 4 terms, what I'm going to do is I'm going to kind of group the first 2 terms, and then I'm going to group the second 2 terms. And I'm going to do what's called factor by grouping. So in these first 2 terms, I'm going to look and say, okay, what can I factor out here? Well, there's not a number that I can factor out, but I can factor out variable, and I can factor out an x squared. And if I take out an x squared from both terms, I'd be left with a 2x in my first term, and I'd be left with a positive 5 in my second term. Then, the big key here is I always want to take this sign with me. Then I look and I say, okay, what's the largest number that I can factor out of these two? Well, the largest number between 8 and 20 is going to be 4. But notice that it's actually, I'm taking out a negative 4. So I'm factoring out a negative 4 from both of these. So a negative 8x divided by a negative 4 will leave me with a 2x. A negative 20 divided by a negative 4 will leave me with a positive 5. And all of this is equal to 0. Oh, look. I have two terms here, and both of those have the same factor, 2x plus 5. So I'm going to factor out that 2x plus 5, and I'm going to put my leftovers, x squared minus 4, in the other factor. Now I can also factor this x squared minus 4. This is actually what we call a difference of squares. I can take the square root of x squared, and that's an x. And I can take the square root of 4, which is 2. And wherever I have the difference of squares, that means I'm going to have a positive and a negative. Now, I didn't really have to do that in order to solve, but it's nice to go ahead and have it completely factored first. So I have my 3 factors, and notice my degree is 3. So I set 2x plus 5 equal to 0, x plus 2 equals 0, and x minus 2 equal to 0. So I get 2x is equal to a negative 5, x is equal to a negative 5 halves, x is equal to a negative 2, and x is equal to a positive 2. So my solution set is going to be negative 2, negative 5 halves, and positive 2. So I want you to try some more of these with the higher degrees of using the zero product property.